All right, so this problem is going to illustrate two properties of theorem 1.2. Um, we're going to illustrate the sum or difference. The sum or difference. Let's put the theorem here. So the sum or difference. Sum or difference. This is saying that if we have some function f of x plus or minus another function g of x, okay, and the limit of this function is L, and the limit of this function is K. If I evaluate this function, and I evaluate this limit, and this limit, and this limit, I can just add the limits or subtract the limits. So what they're saying is that if I do a limit of 4x squared as x approaches 2, I can just add it to another limit of function 3, y equals 3 as x approaches 2, and then I can just add it. Now this one is going to give us a scalar multiple. The scalar multiple is saying that if I have some number, so scalar multiple, if I have some number b multiplying some function, then the limit of this as x approaches some value is actually equal to the limit of this one times this one, so equals BL. So in this case, it's saying that, okay, I can pull out the 4, because that's B, and then I can multiply that one times the limit of the other function of x squared as x approaches 2. So first I split this one and this one. I take the limit of each. Now this one has a constant, so I can pull out the constant and just get the limit of the variable. And so now the limit of the variable, we can just use direct substitution. So this limit is going to evaluate to x squared or 2 squared, so that's going to be 4. So now I have 4 times 4. And the limit of this one, remember, the limit of when y is a constant is going to be equal to the constant. So now I have 4 times 4 plus 3, that's 16, plus 3 equals 19. And that's your answer.